Welcome back, everyone, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 14. Experiment number 14 is called synthesis of soap, and the process is called saponification, and this will be our research experiment. So, the first task I want you to do is I want you to go to our Brightspace platform, make a copy of the lab report template and edit the template as we are going, and make sure you write the answers that will be provided in this PowerPoint. So again, the first thing you want to do once you open up your lab report template, put your name on the top left and put the date in which you are completing the experiment number 14. So again, for every experiment, the directions state in the box below, write one sentence that clearly describes the goal, what you hope to accomplish, and the method used, how you plan to do this to complete the experiment. The sentence should begin to, for example, to observe if toast always lands butter side down when it falls off the table by adjusting the height of the table. So our objective for today's experiment is to synthesize soap via the saponification reaction by reacting a triglyceride vegetable oil with a strong base, NaOH, isolate and purify the resulting sodium salt of fatty acids, and analyze the product's physical properties, appearance, pH, and solubility to confirm successful soap formation. Again, the objective for today's experiment is to synthesize soap via the saponification reaction by reacting a triglyceride vegetable oil with a strong base, NaOH, isolate and purify the resulting sodium salt of fatty acids, and analyze the product's physical properties, appearance, pH solubility to conform or to confirm successful soap formation. Again, you want to pause the video and you want to write the objective. Once you have written down the objective, resume the video and we're going to go on to the next section. So there are some important terminology that you need to know for today's experiment. Again, if you go back to the lab report template, you want to fill in the definitions that we are going to give you right now. So again, pause the video. We're going to go over the definitions, or you can write the definitions as I am saying them right now on your lab report template. So the first one is synthesis. So synthesis is a chemical reaction, and it is the creation of complex chemical compounds from simpler substances through chemical reactions. So you have so many starting materials, and you have one product at the end. This is a synthesis reaction. Now, let's give you the definition of soap. Soaps are usually sodium or potassium salts, and they are made from chemically reacting compounds called triglycerides found in animal fat or vegetable oil with strong bases such as sodium hydroxide NaOH or potassium hydroxide KOH. So, believe it or not, soaps are used by reacting the animal fat with a very strong base. From the lecture, if you listen to the lecture video, fats are also known as triglycerides. And now, a chemical reaction that produces soap from the processes described above is known as saponification. So, saponification is the process of making soap using animal fat and sodium hydroxide. As you can see, there are so many different soap options in the market. You have Dove, Dettol, Nivea. There are so many different types, and they're all made from similar processes where you take animal fat and you react it with a very strong base. And here is the process viewed as a diagram. These are the triglycerides. Again, this is the glycerol backbone, and you have the fatty acids sticking off of the glycerol backbone. This is your triglycerides from oils, and then, or it could be from animal fat. And then we react it with a very strong base. In this case, it's sodium hydroxide, as we learned in the acid base chapter and also in our labs. Sodium hydroxide is a very strong base, and it is an electrolyte. It conducts electricity. So once you react these two, you're going to get back your backbone, which is glycerol. So the NaOH is going to come here and cleave all these positions. You're going to cleave all these bonds, giving us the glycerol backbone. Glycerol has three alcohols sticking out of it: OH, OH, OH. So it is an alcohol. It's a triol because it has three OH units. And once the NaOH, the sodium hydroxide, attacks the triglyceride, you are going to have your salt. So this is your soap, which is a form of a triglyceride, right here, which is a carboxylate. Also, you want to write down the saponification notes in our lab report template. So saponification. Now you start off with esters. Now esters, as you can see here, have the C double bond O that's attached to an alkyl group. So esters could be cleaved back into the carboxylic acid, in particular the carboxylate anion, and the alcohol. As we saw in the previous video, the alcohol is usually glycerol, which is the backbone if we're starting off with a fatty acid. If you start off with a fatty acid, you're going to end up with a glycerol. And if you start off with an ester, you are going to get an alcohol. So, an alcohol by reaction with water and a base. So, the base here would be NaOH. The reaction is called saponification, from the Latin sapo, which means soap. The name comes from the fact that soap used to be made by the ester hydrolysis of fats. That's why it's called saponification, because it's been hydrolyzed. The esters have been hydrolyzed. Now, due to the basic conditions, a carboxylate ion is made rather than a carboxylic acid. Because this is NaOH, the OH is going to remove the H of the acid, giving it a negative charge. Make sure to write that description in our lab report template. This flowchart is very important. It shows us saponification, and there are three avenues it could be used. It could be used in so many different reactions. So the first one, it could be used in acetylation, which is to release the fatty acids from the salts. This can in turn lead to phase separation, which is the process of removing of glycerine containing phase. And then it goes into esterification, which is the formation of an alkyl ester. And then it goes into the removal of alkyl esters and subsequent concentration steps. Saponification is also used in the removal of alcohol residues, which in turn goes into the crystallization of fatty acid salts, which in turn could be filtered, filtration, and subsequent concentration steps. Not only that, but saponification could also have the effect of the addition of suitable mineral salts for metathesis or powdering agents, which can also be used in liquid extraction, which can subsequently be used in filtration and subsequent concentration steps. So, as you can see, saponification is a versatile reaction that could be used in so many things. So, the experimental details, the experiment for today is going to be making soap. We're going to go over the steps. You need to know these steps in order for you to answer the quiz for today's experiment. And after we do the steps, we are going to tell you the assignment that you need to complete for today's experiment. So in this experiment, a saponification reaction will be performed using corn oil and sodium hydroxide to produce soap. Now, step one, you're going to place 20 milliliter of the oil in a 400 milliliter beaker. You're going to add 25 milliliter of 20% sodium hydroxide, which is our strong base solution, and 20 milliliter of ethanol, which is an alcohol. You're going to place the beaker on a hot plate and heat gently. Continue heating and stirring until a paste is obtained. And this is made up of soap and glycerol. You're going to cool the residue. Add 100 milliliter of saturated sodium chloride solution to the prepared soap and stir to mix. This is called the salting out procedure, which removes the soap from the water, glycerol, and excess sodium hydroxide. Filter the soap via a process called vacuum filtration using a Buchner funnel and a filter flask and rinse with ice water. If the pressure of the vacuum is low, take several pieces of filter paper and press on the top of the soap in the funnel to soak up additional water. This speeds up the drying process, and the soap obtained is usually a compact circular disc. Dry the soap by leaving the vacuum on as long as possible. Place a filter paper on a watch glass and place the soap on it. Store the soap until it completely dries. The equipment you're going to be using for this is the graduated cylinder, hot plate stirring rod, filter paper beaker, watch glass, and the Buchner funnel and filtration flask. And you're going to use the corn oil, olive oil, linseed oil, and 20% sodium hydroxide, the saturated sodium chloride solution, ethanol, and the ice water. So, what you're going to do for this experiment is you are going to complete the. So, again, make sure you fill out the objective, complete the synthesis, soaps, chemical reaction, saponification definition. And here is a summary of what you need to be doing for today's experiment. Today's experiment, as you saw, this is the research experiment. So, you're going to write a concise, well organized paragraph, 200 to 300 words that summarizes the key concepts, procedures, and outcomes from the provided experiment text on soap synthesis saponification. It's about 200 to 300 words. The font is Times New Roman or Calibri 11 to 12, double spaced. And make sure to upload the paragraph to our usual Google, to our Bright Space. So make sure here are the questions that you need to address. And again, you're going to have access to this uh, uh, Word doc. You need to answer what is the main goal of the experiment, state the intended product and the reaction type, which reactants and reagents are used. So name the oils and base used in any important solvents or additives. What is the overall chemical idea of saponification? Explain in one sentence how esters are converted to soap and glycerol under basic conditions. What are the critical procedural steps? Make sure to write all of the steps. Summarize the key steps such as mixing, heating, salting out, vacuum filtration, drying. What is the purpose of salting out? So, again, go back to our lesson. And what is the purpose of it? And why do we use NaCl in that step? What physical properties or observations confirm successful soap formation? Refer to appearance, pH, solubility, texture. Mention safety or practice considerations briefly. Reason for using ethanol, handling NaOH, drying techniques, and the optional one short sentence suggest one important or one improvement or one variable you might change to test the effect. What you could do is as well, if we go back and you look at all these companies, you can pick a soap company and also talk about what sort of how is this particular company producing its particular soaps. You can also add that to your paragraph and submit your um, assignment by next week. Thank you. So the announcements for today is that you watch the assigned video. Very good. Make sure to complete the quiz posted on Bright Space based on the experimental video. Submit the lab report using the template that is provided. If you have any questions, please email me. Thank you and see you soon.